Welcome to this session. My name is Barbara Gochalia, and in this session, we are going to look at the theory of production or the theory of the farm, which we briefly looked at. Actually, when we talk about the theory of a farm, we are actually talking about the theory of production and costs, right? So these ones work together. Previously, we had looked at the theory of costs, but you are going to realize that they are related. They are related because it is very difficult to incur costs when you are not producing. Production goes with incurring costs. It is very difficult. It's practically impossible to incur costs when you are not producing, or to produce when you are not incurring costs. So these two work together, production and costs, and you are going to realize that they are related in one way or the other. So the theory of the farm describes how these farms make cost minimization production decisions, and how these farms, how the farms' resulting costs vary with their output, right? So the theory of the farm can best be understood in terms of purchasing decisions of consumers, and also it can also be perceived or understood in terms of the production technology, in terms of the cost constraints, and in terms of input choices. So the factors of production here, when we talk about factors of production, we are basically talking about inputs in the production process, what we use in the production process as inputs. For example, labor is an input, capital is an input, raw materials are an input in the production process, right? So the production function will be a function of these inputs. The production function will be is illustrated by output being a function of these inputs that are used in the production process. For example, if we are using only two inputs, capital and labor, K stands for capital and L stands for labor, right? Of which this capital can be in form of machinery, it can be in form of buildings, right? Capital here, we are talking about, for example, machines, we are talking about buildings, right? Right? So that's how the production function looks like, and it will show the highest amount of output that a farm can produce for every for given combinations of input. So like we looked at short run, we actually looked at short run and long run periods of the farm, where we saw that in the short run, we have two inputs in the production process, where we are one of them is the variable and another one is the fixed, right? For example, we saw that in the short run, if we have capital and labor, labor will be variable, capital will be fixed. Then we saw that in the long run, all factors here, since we are looking at the production, in the long run, all production inputs will be variable. For example, if we have capital and labor in the long run, capital and labor will be variable. They will be variable, they will be changing. So let us look at production with the one variable input. Production with one variable input. In other words, here we are looking at two inputs in the production process, where one input is the variable and another one is fixed, and specifically here we are seeing that labor will be variable, will be changing, and the capital will be fixed, right? For example, in this particular table, we have the amount of labor here, of course, the number of workers employed here, and then we have the corresponding capital. The capital could be in a form of can be in the form of machinery plus buildings, because those ones, they will not change in the short run. Actually, this one happens in the short run period of the farm, right? So remember, when we were looking at costs, we were looking at costs, for example, and we were seeing that fixed costs were not changing, isn't it? But now here we are looking at it in the perspective of production, where we are seeing two factors of production here, right? The other ones, we had variable costs and the fixed costs, but now here it's in the same story, right? But in the perspective of production, where we are having labor being variable and the capital being fixed. That's why we have, I'm assuming these ones are dollars in dollars. Of course, you cannot have Ugandan shillings in these small amounts, small figures. So here it means that the capital is fixed, it's not changing. So that's why we have $10, right? Throughout, if they are dollars, right? Then the output, total product. Output is also the same as when we talk about total product. TP is the same as, not TP in terms of toilet paper, no, total product, right? So total product is also the same as Q. We can call it either total product or Q. You can simply call it total product or Q. Are we together? So this is the total output produced for every corresponding amount of labor employed and capital, right? And then also we have a column here of average product, where we see that the average product is the same as total product over, of course, this one will be average product of labor. It is average product of labor, because labor is the variable factor here. So this is average product. When I put a small L there, it is average product of labor. It can be average product of labor or average product of capital. So if it is average product of labor, it will be total product over labor. Total product over labor, which is the same as output Q. Of course, total product, we've seen it is the same as output. Total product, total output. Output over L. So that is average product of labor. It can also be average product of capital. APL, average product of capital. So average product of capital will be total product over capital. Total product divided by the corresponding capital. Or it can simply be output. It can simply be total product is total output divided by K, capital. Right? Then we have marginal products, right? Of course, now here, since it is labor, it is marginal product. But it can also be marginal product of capital. So it can, here we are looking at, we are calculating marginal products of labor, but it can also be a marginal product of capital. So MPL will be marginal product of labor, and the marginal product of labor will be given by change in total product over change in labor. Change in total product, change in total product over change in labor. Or it can simply be change in Q over change in L. Change in Q over change in L over change in labor. So the average product of labor here that we are calculating, it will be total product, which is output, right? Total product. You are leaving this one blank because it was 0 divided by 0, right? So here it will be 10 divided by 1, which is what? 10. Then here it will be 30 divided by 2, which is 15. 60 divided by 3, which is 20. Right? So that is the average product of labor, but it can also be average product of capital, where we are dividing the total product divided by the corresponding capital, which is 10 all throughout. Then here it will be changed. The story is the same with the theory of costs, only the label changes. So here marginal product of labor, here we shall get the change. We leave this one blank because you cannot have marginal product of labor when you have 0 labor employed. So we come here and this one will be 10 minus 0 divided by 1 minus 0, which gives us 10, right? Then this one will be 30 minus 10 divided by 1 divided by 2 minus 1, which gives us what? 20. Are we on the same page? Then this one will be 60 minus 30 divided by 3 minus 2, which gives us what? 30. And the story continues. So the logic is the same with the theory of costs. Here what is changing is the labeling, right? So if there is any question there, you are free to ask.
No question, we continue.
We continue. All right.
Yeah, in relation to cost, I think we can understand that very well.
All right. So that was the production with one variable input labor. Then we have average and marginal products. Average product will be the output per unit, output produced per unit input, right? Then the marginal product, of course, the other side it was average cost, marginal cost. But now since here it is production, average product, marginal product. So the story is the same. Marginal product, anything marginal is anything, extra is anything additional. So marginal product, extra output produced as a result of employing an extra input. For example, when you employ one more worker, you expect to produce extra output, isn't it? So that extra output you produce is as a result of employing one more laborer or one more worker. is what we call marginal product, which we have seen that with the average product of labor is the total product, which is Q, which is also the same as Q over labor. Marginal product of labor will be the change in total product over change in the labor, which is the same as change in the Q divided by change in L. We are still looking at production with one variable input, which is labor here in this perspective. So the other side of the theory, of course, we looked at the law of diminishing returns, or the law of diminishing marginal product, or the law of variable proportion, which you can call the law of diminishing returns, or the law of diminishing marginal product, right? So with this law here, we shall realize that we saw what the law of, I believe we explained, that law was explained when we are looking at the theory of cost, if we can remember. But here, this graph basically is explaining the law of diminishing returns, or the law of variable proportion, And in this law, we assume that it is a production with one variable input. And remember that we saw that with that law of diminishing returns, it states that if a variable factor is added onto a fixed factor, output increases up to a level where output will increase first at an increasing rate, but then after that continual addition of a variable factor onto a fixed factor, output will begin to decline. And the law of diminishing returns assumes that there is no change in technology. Right? So here we see that this graph here, we are seeing that the total product, which is the total output here, is increasing. We basically have 3 stages here. We have 3 stages. We have this stage here, stage 1, stage 2, and the stage 3, right? So here we are assuming that, for example, it is we are assuming that land is our fixed factor. Is not changing, and fertilizer is our variable factor. If we are looking at it in the perspective of agriculture, so land here is a fixed factor and the fertilizer is a variable factor, because we can change the amount of fertilizers that are being applied to the soil or to that piece of land. So we are assuming here that fertilizer is a variable factor, right? So here, of course, we are looking at it in the perspective of production, right? If it's agricultural production, for example. So in this part here, first stage here, where we have number 1 here, it shows that as you increase, if it's a piece of land, you are a farmer, and you apply fertilizers. As you apply fertilizers, the crop yields will increase, isn't it? They'll be increasing at an increasing rate, right? So that is stage 1. And at that point, here, total product, this is the total product curve. At that stage, the total product curve will be increasing at an increasing rate. And here also we have the average product curve and the marginal product curve. I believe we know what average product and the marginal product means, right? So here at that stage 1, the average product curve and the marginal product curve will also be increasing, Then in stage 2, as you continue to add more fertilizers to that piece of land, output will increase, but output will be increasing, but it will be positive, and it will be increasing, but at a decreasing rate, right? It will be like, it will be positive, yes, but it will be increasing at a lower rate. So that is stage 2. And here with stage 2 now, this was stage 1, this is stage 2 now. There we shall begin now. The average product now will begin to decrease now. Even the marginal product will now begin to decrease. So now there is a peak here. There is a peak here at point C, where the continual addition of fertilizers, the crop yields now will stop increasing. They'll reach a peak there, and at that peak there, the marginal products now, the marginal product, it's actually this peak here, if I can put it there, right? That peak there, I can call it D. So at that peak there, where there is, I can call it D there. At that point, that will be a peak whereby continual addition of fertilizers, the output will cease to increase, the crop yields. So at that point there, the marginal product will be at 0. The marginal product will be at 0, right? And what happens is that beyond that point, when you continue to add fertilizers, now the crop yields will begin to do what? You have to have reduction in crop yields. Why? Because at that point, this land is not changing, it's fixed, that plot of land. So even this, just imagine you've added fertilizers for the last 5 years, or even for the 1 year, and you're not changing. So we even know that this soil gets exhausted. So as long as the soil has got exhausted, even if you continue adding fertilizers, you'll even just, the crop yields will just begin to reduce. So that's what it means. So here at that point there, we shall have the marginal product now beginning when the total product is now declining and declining, then the marginal product here will now get to negatives. If it goes beyond this vertical, this horizontal axis here, it will be now in negatives, right? It will be in negatives, isn't it? Because of course we know this side is negatives, and also this side is what? Negatives. So it will begin to be, the marginal product will be negatives, the average product will be reducing, and the total product will be reducing at a decreasing rate. Reducing literally. So that's how the law of diminishing returns works for the case of production with one variable factor. And of course, here we've been looking at one variable factor, which is fertilizer, and the other factor is fixed, which is the plot of land. But that one only works when the assumption is that the law will only work as long as it assumes there is no change in technology. Otherwise, if there is change in technology, the law, what if, there are these people that have made, they do those, I don't know how they call them, hybrid seed varieties, where you will see a mango growing in 2 days, an orange which does not have seeds, it's growing in 1 month, that kind of thing. So that is technology, literally, where we are having, they are called, what are they called? GMOs. Genetically modified what?
Products.
They are not products. Those, for example, varieties that they are genetically modified. So you find an orange growing in one day, but it does not have seeds. You've seen those oranges. So those are GMOs, and that is technology. Basically, they are using technology to make sure that those crops grow in the earliest time possible. That's what was happening during the pandemic. When people were not working, everyone was indoor. They were literally just growing those big onions, the big oranges, because for them they were growing in like 1 month or even less. People were not cultivating. Everyone was hiding in the house because of COVID-19. So that is technology practically, and they are the law of diminishing marginal returns, or diminishing marginal products, or the law of variable proportion will not work. Will not work where there is change in technology. So the law of diminishing marginal returns was central to the thinking of political economist Thomas Malthus. You remember Thomas Malthus on population, right? So Thomas Malthus was an economist that he actually talked about population and environment. He talked about population, environment, and resource scarcity, right? Where he said that that population was growing at a geometric rate, and yet the resources like food we are increasing at an arithmetic rate. In other words, the population was growing at a higher rate than the rate at which the resources like food, the supply of resources like food, we are growing. And as a result, he said that if nothing was, he said that we would reach a point, a situation would reach whereby the population would be equal to the amount of food, right? And that one would be an equilibrium, actually, where would be experiencing a point of equilibrium, a point of crisis. It would be a point of crisis where people would be eating to survive, right? And beyond that, if population grew more than beyond that point where population would be greater than the amount of food or the resources, then it would have people would begin to starve. People would begin to die of starvation, hunger, and then he actually gave advice. He gave advice, and he said that actually his advice was he talked about the positive checks and the preventive checks in order to curb the situation. He talked the positive checks were basically the natural factors, where he said that in periods of war, in periods of famine, and in periods of these epidemics, that people would die, and because of those natural calamities, people would die, and this will reduce the population and curb the situation. For example, we've had people dying during the COVID-19 pandemic. That was Thomas Malthus's thinking. And I believe that is true, that because that, isn't it true that during periods of epidemics, periods of war, periods of famine, people die. And when these people die, these are natural calamities that help in reducing population. So that was his thinking, his reasoning when he was talking about the positive checks to control population. So I believe even in this COVID-19 era, people have died, and that has been a positive check in reducing the population. So this man was right in some way. Then he also talked about the preventive checks. the preventive checks for him, his advice was that people should stop marrying, or if they get married, they should give birth to few children. But literally he was telling people to abstain from what? From sex, people to abstain from marrying, such that the population would not increase. But that was his thinking by then, in the 1700s for sure, right? 1700s for sure. So, however, this theory, Thomas Malthus, was criticized on the number of grounds. So here we realize that the law of diminishing marginal returns, for him, actually, he was considering this law. This law was applicable to his theory. But however, we see that Thomas Malthus was criticized on the number of grounds, where his critics said that, no, look here, that was way then in the 1700s. What if there is technology improvement, increase in technology, where people are growing these mangoes and oranges in 2 days? Yeah, in 1 day the mango has grown, it doesn't have seeds. In 1 day the orange has grown, it doesn't have the GMOs, right? So that one, with technology you can increase food production. When you use fertilizers, that is technology. When you use machines, combined harvesters, tractors, that is technology in agriculture, where, for example, you're increasing the crop yields. So that one would outrule Thomas Malthus's theory, right? So that's it practically. All right. We are still looking at production with one variable input here. In this perspective, we are looking at labor productivity here. Means average product of labor for an entire industry, right? So with the productivity, we are looking at how much output is produced per unit for each unit of labor, right? When we talk about productivity, we are looking at how much output is produced for each unit of labor. So stock of capital, we are talking about the total amount of capital available for use in production. Then technological change, we mean development of new technology, allowing factors of production to be used more effectively. For example, we can use the fertilizers, the tractors, the combined harvesters in agriculture, even in the manufacturing sector, where industries are using machines in the production process. So that was the production. That was the production with one variable input, which practically works in the short run. And then we can also have production with the two variable inputs. Production with the two variable inputs, where we are looking at, for example, if it's capital and the labor, these ones will be variable, they will be changing. So in production with the two variable inputs, we are seeing capital and labor. And production with the two variable inputs, that's when the isoquants come in. That's where the isoquants come in. So these curves that you see here, So that curve that you see there is called an isoquant. An isoquant. And call it Q here. And this isoquant is a locus. It is a locus of points, right? A locus of points. We have different points along this isoquant that shows combination of two inputs. In this case, it can be capital and labor. That shows combinations of capital and labor, or two factor inputs in the production process that that can be attained. That can be attained. So it is a combination of a locus of points that shows combinations of two inputs, capital and labor, that combinations of combinations of two factor inputs to yield a given amount of output. I don't know if we are getting that. For example, if we have that, we have A, that point here, there to be A, that one to be B, that one to be C, right? So all those are combinations, right? For example, this one can be K, let me say K1 with L1. Another ones you can use one, maybe one machine and one laborer employed. Then here you can have maybe two machines. I'm just assuming. Of course, this one cannot be. Let me see this. Let me say this is one. This is two. Right. So this is L2. And then this is L1. So for example, you can have two machines that are used, but one laborer employed to operate those machines in the production process. And then you get a given amount of output. Then also you have like here one machine used, maybe one machine, one laborer used. Then you get output there. So that point there B represents the amount of output that you will get using various combinations of two inputs, right? So that is an isoquant. In other words, here it means you can change, you can vary the capital and labor. You can either increase the machines used and reduce the labor, or you can increase the labor and reduce the machines. Are we together? So there it means that you are having production with the two variable inputs. Remember that in the short run, we are only having a production with one variable input, where we are seeing that the machines were not, there was no change in technology, right? There was no change in technology. You are just, there was no change in technology, but here you can increase the number of machines used, even the technology of those machines use, that kind of thing, such that you increase output, right? All right. Then for this, we have what you call the substitution among inputs. What you call the marginal rate of technical substitution, right? The marginal rate of technical substitution here, if we have capital and labor, it will be the rate at which capital can be substituted for labor, or the rate at which labor can be substituted for capital. For example, you can substitute labor with machines, right? Or you substitute machines with labor. So that rate is what you call the marginal rate of technical substitution, which will practically be the slope of the isoquant, which will practically be the slope of the isoquant. So the slope of the isoquant will be, if this is capital, the vertical axis is representing capital, and the horizontal axis is representing labor. So the change, the negative change, it will be a negative change in capital over the change in labor, will give us the slope of the isoquant at that point. For example, here, or it will give us what we call the marginal rate of technical substitution, the rate at which capital can be substituted for labor, as long as output remains constant, For example, here we see that the capital, we have these values of capital 1, 2, 3, 4, 5. Then here we also have 1, 2, 3, 4, 5. That is, those are the values for labor per year. And we see that here, for example, for this isoquant 2 here, we realize that the marginal rate of technical substitution will be, for example, in this perspective, we are having 4 minus 3, right? Here we are having from here up to here. 1, this is 2, this is 1, right? So subtract 2 minus 1, right? And then also subtract along, of course, the horizontal axis, and then along the vertical axis, we are considering 3 and 4, right? 3 and 4, right? So practically here, it is going to be, what is it going to be? Change in capital over change in labor. What is the change in capital?
It is 4 minus 1. 4 minus 3 equals 1.
And change in labor?
Labor 2 minus 1. Which is 1.
-2
Okay, there it can be 1 if we are considering this section here. If we are considering this section here, and if we are considering this section here. Right? But if we are considering from here, from 3 up to 5, that one will be what? It will be 2 over 1. Eh?
Yes.
All right. So at the end of the day, we know that we can, if we are in the long run, we can have 2 variable inputs. We can change, we can alter, right? We can change the amounts of capital and the amounts of labor to be able to give the same level of output. In other words, these isoquants by definition, iso means the same. Quant means quantity, isoquant. So that curve here, this curve here, is called an isoquant. So it is showing combinations combinations of two inputs in the production process, for example, capital and labor, that yield the same level of output, So for example, at that point there, we have a combination of capital and labor. Even at that point there, we have a combination of capital and labor. Even at that point there, we have a combination of capital and labor. But at the end of the day, for example, if they are giving us maybe 75 units of that particular product produced, all these combinations are able to give us 75 units of the product produced at the end of the day. This one can be K1. This one can be K1. This one, maybe you're using one machine here. Here you have added the second machine. Here you've added the third machine, right? And of course here, you can add the machine, but when you are reducing the labor, you are substituting, right? So here, if you have one machine, you are using more of labor, right? Here, when you come to the second machine, you purchase maybe the second machine. Here you are reducing, you have reduced on the labor, isn't it? Then you purchase the third machine. Here you have labor 3. You have literally reduced the amount of labor. So, but at the end of the day, you're able to get the same amount of output produced. So that's why it's called ISO quant. ISO means the same. Yeah. Then quantity, it will be quant, ISO quant, quantity, isn't it? So ISO, the same quantity, ISO quant. So an ISO quant is that locus of points. It is a locus of points that shows a combination. This is a combination. A is a combination of capital and labor. B is that point that shows a combination of labor and capital. So C is that combination that shows combination of capital and labor. That a combination of two inputs in the production process, for example, capital and labor, that yield the same amount, that yield the same output. So I hope we are together up to that level. Now someone will be asking, now, Madam, why are we studying all these things? Of course, at the end of the day, it helps managers or business people to be able to know how much to produce. At what cost? Of course, at how much to produce, at what cost, of course, there is possible cost. So that was the ISO quants when we have two different factors of production. But we can also have ISO quants when these inputs in the production process are perfect substitutes. So if the inputs in the production process are perfect substitutes, then our isoquants will be in that, they will be in that direction. They will be in that direction. So that's how an isoquant looks like. It will be that curve showing possible combinations of two inputs, for example, capital and labor, that yield the same output, And when we have many of those isoquants on the same graph, it becomes an isoquant map. So if we have more than one isoquant on that same graph, that set of those isoquants is what we call an isoquant map. Right. So we looked at returns to scale, and I believe when we were looking at the theory of costs, and that's why initially we started, I began by informing you that the theory of production is related to the theory of costs, because it is very difficult to actually incur costs when you are not producing anything. So we looked at the returns to scale, and we basically saw, when we were looking at the theory of costs, and we saw that these returns to scale, they happen in the long run. They happen in the long run where factors are all factors of production are variable, or where inputs into the factors or into the production process are variable, and we experience what we call increasing returns to scale, which is the same as economies of scale, and then constant returns to scale, and then decreasing returns to scale, which is the same as these economies of scale. All right, so this curve here shows shows constant returns to scale here, because we saw that with the constant returns to scale, when you increase, for example, input, when you increase input by a given proportion, even output will increase by that same proportion. So we are seeing here that the isoquants are increasing actually by the same rate, Here we see a rate of 10 here. But then this other one is representing increasing returns to scale, returns to scale, where we saw that when you increase input by a given proportion, output will increase by a proportion greater than that input that you have increased. All right. There ends our session. Thank you for listening.